the Chapter 2 review packets since some people were out and we're not having the test till Thursday due to Justin. All right, I got to share my screen. Bear with me a minute. I'm going back to COVID. Share. It should work. Okay. So the big review packet, we'll start with that. I want to make this bigger. All right. These first two questions are using the limit definition. So you need to look at this. If this was f of x plus h minus f of x, you can see it's a limit definition for x squared. And the derivative, which this is 2x. So pretty straightforward. Now looking at this, you would deduce, number 2, this is going to be the derivative of sine, since it's f of x plus h minus f of x. Derivative of sine is cosine. So what's cosine of pi over 6? Root 3 over 2. Forget about 3. It's a bad problem. I'm not going to ask that. Now, when we ask for tangent lines, we need a curve, slope, and a point. So in this one, they gave you the point, 4, 0. So we get f prime of x is negative 2x, Mr. Lee bar. So the slope is negative 8. And then we write y minus 0 equals negative 8x minus 4. And A is the correct answer. This one, you could do the product rule, but why bother? Why not just multiply this out? Get 4x cubed minus 2x. And the derivative of that is 12x squared minus 2. At 1, the slope equals 10. Now, notice this is just asking for the slope of the tangent line, not the tangent line itself. This is a good one just to illustrate when we do the quotient rule, we get this. Minus x minus 1 times 1 over x plus 1 squared. Now you're just looking for what is the slope at 1, so I wouldn't do any simplification. Plug in 1 here. 1 plus 1 is 2 times 1 minus 1, that's 0 over 4. So you get a slope of 1/2. And then the point is, well, the point is 1, so you got to figure the y value. Well, it's going to be 0 over 2, which is 0. So this is your tangent line and point slope form. And when you multiply through by 2, you'll get B. This wants to know when you have a horizontal tangent, so you need to take the derivative, but you need to set that equal to 0, because that's when you have a horizontal tangent. And it just so happens that the numerator simplifies to negative 70x. Here's the denominator, but if we set this equal to 0, we only care when the numerator is 0 and you get x equals 0. Sketching graphs. All right, here's the technique. First, easiest points to find. If this is f, the slope is going to be 0 here, here, and then I mark D. So immediately I can mark those points off on f prime. So I have a 0 here, here, and this should be a point. Now, if to the left of A, f is increasing, so f prime has to be positive. But you see it's positive coming down to 0, so you would draw this. Now, take a deep breath. Between A and B, the function is decreasing, so f prime is negative. But remember, it's going to have to come back to 0. So that's why you then draw this. Between B and D, the function is increasing again, so f prime is positive. So if it's 0 at D and it's positive, it has to do this. And then after D, the function's decreasing, so f prime is negative and it goes down. So you should be able to do the second one using that technique. These are all just straightforward derivatives. And again, on the test, unless they ask where this is 0, you don't have to simplify. Same thing here. Now this one I bring up, so I have to pick on Mr. Trafton. But you could do the quotient rule with this, but it would take longer. Why not just say -4x plus 5 to the -1/3, bringing this up to the numerator? Then I can just apply the power rule. -1/3 times -4 is 4/3. X plus 5 to the -4/3. Don't get rid of that 5. The derivative of x plus 5 to the -1/3 is -1/3 x plus 5 to the -4/3. Right now, if you're asked, you want to find the limit definition and use the limit definition to find the derivative of this function. You need to set it up, f of x plus h, which is this, x plus h squared plus x plus h, minus f of x over h. You'll have tons of cancellation, and the h's will cancel, and 2x plus h plus 1 as h goes to 0 is 2x plus 1. Of course, you could check this by saying, well, the derivative is 2x plus 1. But woe to the person who doesn't do the limit definition if I ask for it. You're getting no credit. Now, here's one where they're saying find g prime of 3. So instead of g of x plus h minus g of x, I do g of 3 plus h minus g of 3 divided by h as h goes to 0. Now you're going to go through some algebra, and here's where you'll probably get screwed up. I found a common denominator here, but this divided by this divided by this equals -h, 3 minus h, over 3 plus h times 3 times h. H's cancel, and you get -1/9. Some more practice. Don't be bothered by the pi, just bring it out. The derivative of this is 5 pi x to the 4th. Derivative of any constant is 0. Simple quotient rule here. This is pretty straightforward since you know your trig derivatives. This is a nasty, it's hard to see on here, but doing the quotient rule here, this is why I say you will not be asked to simplify. I write this as x to the 1/2 plus 3 tan x times the derivative of the top, 3 plus cosine x, minus 3x plus sine x times the derivative of the bottom. You are perfectly okay to leave that as 1/2 x to the -1/2 plus 3 secant squared, all divided by this squared. This wants to know where the slope is 0. So once you take the derivative 3x squared plus 2x, you have to set that equal to 0. And you'll have, in this case, factoring out the x equals 0 or x equals -2/3. A good one over here, testing your algebra skills. When you do the derivative here, the numerator collapses down to 1 over x plus 1 squared. This never can happen. So your conclusion would be there are no horizontal tangents on this function. And if you graphed it, you'd see that. Where a function's not differentiable, anytime you take the derivative and you've got an x in the denominator, it's not going to exist at 0. Any polynomial is going to be perfectly fine. H prime is 6x plus 1. That's differentiable everywhere. 6 is not tested on the test. Now what do I need? Oh, here, differentiability. Oh, I'm looking again at this amazing Blackbaud system here. Who did this? All right, and it's just reiterating. I want to make this a little bigger. For you have a function like this, piecewise function. If you're asked if it's differentiable, you got to find out, does the limit exist first? So the limit, and this should say at x equals 0. Sorry about that. It's not 2, at 0. So I get the limit from the left at 0. I use this function and I get 1. Limit from the right, I use this function and I get 1. Therefore, the limit exists, and that's equal to f of 0, because f of 0 is 1. So it's continuous. The limit exists and it's continuous. Now I go to what is the slope from the left? I'm going to take the derivative of this, and I get 4x at x equals 0. I get 0. But from the right, it's 4. Those don't match. So this function is continuous at 0, but it's not differentiable. And then this would be very straightforward. When you take the derivative, you end up with an x in the denominator. It's not going to be differentiable at 0, but everywhere else. All right. Let's see. Stop sharing.